Okay, this is section 4.0, starting off chapter 4 with a section called GCF and LCM of monomials. Real quick intro, the term monomials basically means like an expression that's only one term. I'm going to write some stuff down kind of not randomly, but the kind of stuff that you don't need to write down on your paper. But an example of a monomial would be maybe 3x. Okay. Another example might be 5xy squared. Okay. And you know what? Just something like -8 counts as a monomial. Just stuff that's like one term. But if, just to kind of compare that with something else, compare and contrast, if I had something like 9x squared minus 2x, that is an expression that has two terms. So again, and therefore we would actually call that a binomial. And if I put another, like a third term in here, plus whatever, plus 5, doesn't matter, and now it's 3 terms, that could be called a trinomial. So a monomial would be an expression, like a polynomial expression, that only has one term. And let's start with, let's start going with the notes, I guess. And maybe there's some other background information, but I guess I'll just mix that in as we go. So let's start, okay? The notes start by saying, to find the greatest common factor, which that's what we're going to abbreviate as a GCF, of a set of monomials. So we have like 2 or more separate monomials when we go to find the greatest common factor. We're going to find the GCF of the numbers and the GCF of each of the variables. After finding these, we're just going to multiply them all together to get like the overall GCF of all of the monomials, okay? So here's what they mean by a set of monomials, okay? Since GCF stands for greatest common factor, you need at least 2 different monomials that could have stuff in common. All right? Maybe I'll get back to that in a second, that concept. But I definitely need to kind of sort of pause or kind of like, pause for a second just to talk about what is a factor. All right? That's a big vocabulary word in mathematics. You have to know what a factor is. So if I just kind of, go off on the side for a second and start talking about what are all the factors of 15. All right? And let's just cut to the chase. All of the factors of 15 are 1, 3, 5, and 15. Those are all of the factors of 15. And what are all the factors of 12? Well, those are all the factors of 12. 1, 2, 3, 4, 6, and 12. So factors is like a factor of a number is a number that can be divided into it cleanly, right? Now, if I said, what's the GCF of 15? What's the GCF of 15? that doesn't really make any sense because, you know, when you start talking about the greatest common factor, you need to kind of say what's the GCF of 15 and 12, you know, because you need a couple different numbers to kind of like compare their factors. Because GCF like literally means like what's the biggest factor that 15 and 12 have in common? What's the largest factor that they both have in common? And if you compare these two lists, the greatest common factor, you know, the biggest one that they both have, is really just 3. 15 and 12 both have a factor of 3, and it's the greatest one they both have. Okay? So, there we go. So that's the first part we have to do. Kind of like back here it said, find the GCF of the numbers, then find the GCF of each of the variables. So now we move on to the x's. Now this is actually a pretty easy shortcut. So when you're finding GCF of variables with their powers, the shortcut basically is you compare the powers on the variables. So we got x squared in this monomial, and we have x to the 4th in the other monomial. And you simply go with the smallest power that there is for the x's. That's something you probably want to write down, like in the margin over here, okay? Like something like just use the smallest exponent for each variable, or something in your own words that pretty much means the same thing. Like that's it. So you got x to the 2nd and then x to the 4th. You go with the smallest exponent you have for the x's, even if that exponent is technically 0. Okay? Like if one of the monomials doesn't even have an x anything, you can pretty much just think of that as x to the 0. And that counts, you know, like x to the 0 would be definitely the smallest power. But that's not what we have here. I just want to say, you know, again, you go with the smallest power, even if that smallest power is technically a 0. What happens with the y's? Let's move on to the y's. We got y to the 5th in this monomial. And what's the power over here? Well, it's not 0, it's a 1. The power there is 1. So what's the smaller power? 5 or 1? And maybe I should have wrote it here, actually. So what's the smaller power? Well, the first power, of course. So the GCF of y to the 5th and y is just y. And therefore, now you just, the overall GCF, you just multiply all those together. You just put them all together. And the overall GCF is 3x squared y. Okay? To find the least common multiple, so we're going to change gears because now we're talking about multiples. All right? Now, you have to know the difference between multiples and factors. Let me use a quick, and again, you don't have to write this down on your paper necessarily, but if I ask you for all the factors of 20, you would say 1, 2, 4, 5, 10, and 20. That's the factors. But if I asked you for all the multiples, okay, the multiples of 20 go like this. 20 is a multiple of 20. 40 is a multiple of 20. 60, 80, 100. And this actually keeps going forever. There's an infinite number of multiples of 20. So that's basically, in a nutshell, that's the difference between the concept, the vocabulary definition of factors versus multiples. So here, we're about to start to kind of find least common multiples of a set of monomials. Well, it's kind of similar. We kind of divide and conquer, right? We find the LCM of just the numbers, and then we find the LCM of each of the variables, and then we multiply them all together. We put them all together. Just like with GCF. Except with GCF, we're looking at the biggest factor that all the monomials have in common. Here, we're actually going to be looking for the smallest multiple that all the monomials have in common. So here's our example. We're going to find the LCM, the least common multiple of 3x cubed y squared and 4x to the fifth y to the fourth. So we start with the LCM of just the numbers 3 and 4. So what are all the multiples of 3? Well, right here, 3, 6, 9, 12, 15, and it goes on and on and on forever. What are all the multiples of 4? 4, 8, 12, 16, and it continues forever. And so now we have to find, what are the multiples they have in common? More specifically, what's the least common multiple? What's the smallest multiple that they have in common? And if you compare the lists, that could potentially go on and on and on more if you needed them to. The smallest multiple they both have in common is 12. So the LCM of 3 and 4 is 12. Now, moving on to the variables, this is going to be a little bit different. When it came to GCF, remember back here, for GCF, we found the smallest exponent for each variable. Well, what do you think is going to happen here? Maybe your instincts are saying that we use the largest exponent for each variable. So that's the shortcut for LCM. We're going to use the largest exponent. So as far as the x's go, what's the LCM of x to the third and x to the fifth? You just go with the larger one, x to the fifth. What's the LCM of y to the second and y to the fourth? The shortcut is just go with the y to the fourth, the larger one. And now for the overall LCM of these two monomials, just put them all together. 12, x to the fifth, y to the fourth. And that, as they say, is that for 4.0.